think that solar production of electricity is very important because it's a renewable method for making the electricity that we rely upon every day. This comes from a source that's almost always available to us, the sun. In countries that are developing a middle class like China and India, the demand for electricity is growing much more rapidly than it is in the United States. And therefore, they may as well adopt a renewable strategy which has so many advantages in terms of clean air and security and ultimately economics.
CSP is concentrating solar power, and it basically is the idea of taking sunlight, concentrating it using mirrors to make high temperature heat that's used to produce steam that in turn turns a turbine. That turbine turns a generator, makes electricity.
A parabolic trough generates heat by focusing all of the sunlight onto a single tube. There's a fluid passing down that tube that gets hot. So it's important to get that receiver at exactly the right point, tracking the sun, its position across the sky. So we have to aim this device that is longer than a football field with a precision of less than plus or minus 1/10 of a degree in order to be able to maximize the energy output.
The sky trough collector is different compared to the previous generations of parabolic troughs. It's larger, it's lighter weight, so that reduces its cost, and it uses some advanced materials. Instead of using glass mirrors, we use Reflectech mirror film. You can slide in Reflectech mirror film as a long sheet, and it achieves a very, very accurate parabolic contour. It turns out that these Reflectech mirror film panels are actually more accurate than glass mirrors. That means we can get to higher concentration ratios, we can go to higher temperatures more efficiently, and it also has an impact on reducing costs.
You simply assemble them and they are adjusted. So they are all focused on the same line. And that improves the optical efficiency.
The concentrated solar plants that we aim to build are typically 100 megawatts in capacity, and 100 megawatts for us is roughly 1,200 solar collectors. Each solar collector is 6 meters wide, 115 meters long.
Solar power uses thousands of mirrors to reflect and concentrate sunlight onto a central point to generate heat, which in turn is used to generate electricity. More than 10,000 tracking mirrors called heliostats reside in a 4 square mile field where they reflect and concentrate sunlight onto a large heat exchanger called a receiver that sits on top of a 550-foot tower. Within the receiver, fluid flows through the piping that forms the external walls. This fluid absorbs the heat from the concentrated sunlight. In this technology, the fluid utilized is molten salt, which is heated from 500 to over 1,000 degrees Fahrenheit. Molten salt is an ideal heat capture medium because it maintains a wider operating temperature range in liquid state, allowing the system to operate at low pressure for superior and safe energy capture and storage. After passing through the receiver, the molten salt then flows down the piping inside the tower and then to a thermal storage tank where the energy is stored as high temperature molten salt until electricity is needed. This technology leverages liquid molten salt as both the energy collection and the storage mechanism, which allows it to separate energy collection from electricity generation. When electricity is required by the utility day or night, the high temperature molten salt flows into the steam generator as water is piped in from the water storage tank to generate the steam. Once the hot salt is used to create steam, The cool molten salt is then piped back into the cold salt storage tank, where it will then flow back up the receiver to be reheated as the process continues. After the steam is used to drive the steam turbine, it is condensed back to water and returned to the water holding tank, where it will flow back into the steam generator when needed. The result is a high-quality, superheated steam to drive the standard steam turbine at maximum efficiency to generate reliable, non-intermittent electricity during peak demand hours. The steam generation process is identical to the process used in conventional gas, coal, or nuclear power plants, except that it is 100% renewable with zero harmful emissions or waste. These plants provide on-demand, reliable electricity from a renewable source, the sun, even now.